Okay, welcome back to another video. This one's on section 2.2, and we're going to kind of go over row reduction and some terminology. And then the next video is going to talk about the actual steps we'll use and go through an example following those steps. So given a linear system, right, so if we've got 3x1 plus 4x2 minus x3 equals 10, x1 minus 6x2 plus 2x3 equals 1. Then the coefficient matrix is the matrix with the coefficients of the system. Right, so 3, 1, 4, negative 6, negative 1, 2. And if we include an additional column for 10, 1, we'll often kind of call this the B column just because of how we write this abstractly, like this vector would be the B vector. Okay. Then we get the augmented matrix, which we talked about in class and in the last video. Right. And an important thing to note, right? So the augmented matrix frequently has this for clarity, this bar, but you need to pay attention to whether or not someone says it's an augmented matrix. This bar is not a guaranteed part of an augmented matrix. You have an augmented matrix if someone says it is, not whether or not it has a bar. Okay, so we talked about this in class and went over these notes. This is just a review. A standard row operation on a matrix is one of the following, right? So we can switch two rows. We can scale or multiply one row by a non-zero constant. Again, that non-zero part's important. And you can replace. So I can add a multiple of one row to another row. And the important thing about these three operations is that they don't change the solutions of our system. Right? So if we use these three row operations to get a more convenient system to solve, then the solutions are going to be the same. Okay, so some terminology. First, a leading entry of a row is the leftmost non-zero entry. Right? So if I'm looking at a matrix, then the leftmost non-zero entry is going to be the leading entry of that row. Okay, so now a matrix is in row echelon form. Right? We call that R, E, F. Right? It's in row echelon form if rows of all zeros are under all the other rows. In other words, zeros are at the bottom. Each leading entry is to the right of the leading entry in the row above it. Right? So there's no columns that contain more than one leading entry. And all entries under a leading entry are 0. So let's look at an example. Right? So the leading entry of this row, right, is the leftmost leading entry. So there's no rows of zeros, so number 1 doesn't apply. Each leading entry is to the right of the leading entry above it. And all entries under the leading entry are 0. Right? So this is in row echelon form. And that is, right, so notice that this 4, it's not a leading entry. It has zeros below it just because, right, this had to be a leading entry and this is a leading entry. But we're not too concerned about this. These are our leading entries. Okay, and then beyond that, a matrix is in reduced row echelon form, RREF, if first it's in echelon form, right, row echelon form, then all the leading entries are 1, and all entries above the leading entry are 0. So for example, right, so to take our last example that we had, right, I made that first entry as 1, I made this entry a 1, and then above it I've got a 0. This entry's a 1, above it I've got a 0. So kind of, if you take these two things combined, that means anywhere I've got a 1, everything above it and below it should be 0. Right? So every leading entry should be the only entry in its column, and everything else should be 0. All right, so then some more definitions. A location with a leading 1 in reduced row echelon form is called a pivot, right? So pivot, pivot, pivot. A column with a pivot is called a pivot column, right? My pivot columns. Any column that's not a pivot column is called a free column. So my second column here is a free column. A variable corresponding to a pivot column is a leading variable. So when I talk about the variables, right, remember if I'm thinking about creating a matrix out of a system, then this like corresponds maybe with x1, x2, and so on, right, up to x4. Right. So a variable corresponding to a pivot column is a leading variable, right, meaning x1, x3, and x4 are my leading variables. A variable corresponding to a free column is a free variable. So here x2, right, would be my free variable. And that's going to be important as we start coming up with solutions. So like the examples we saw in class, free variables are going to be where we kind of define our parameters. x2 can be anything. And you can see kind of why that is whenever I get into reduced row echelon form, right? So x4, if I think about this as if it was an augmented matrix, x4 is going to equal something, right? x3 is going to equal something. x1 plus x2 is going to equal something. So x2 isn't set, it's free. And that covers this video for the terminology. We will have another video shortly in which we kind of talk about the actual steps to row reduce these things, and I'll work through an example. Till next time.